Buenos dias. So today I want to talk about my latest analysis that I did, and it was on Austrian death rates. Especially, I wanted to have a look about the influence of COVID. And the reason for doing all of that was because in Austria, we do have the concept of open data to a certain degree. So we have various um, data sets that are made public available. So you can see that, or I can show that, um, which I think is a very nice concept for countries generally to have. And here you can just get various data sets to various things. So I wanted to have a look at the death rates for the reason that it is very important for politics and also for everything legal related to actually come to a proper death rate of people in Austria, but also the relation to the disease of COVID. And that's why I wanted to have a look at it for my own, especially as correlated to this, there are so many visualizations, so many graphics that are published, and you sometimes I really doubt the results that they try to communicate, or in general, I doubt everything they try to communicate sometimes. And with open data, you have the nice possibility to actually have a look on the data yourself. And what I did is I created a GitHub repository and just named it COVID analysis, very basic, and added a little bit of information. So you can have a look at this for your own if you like to. As I said, and I linked this to the corresponding Python notebook, Jupyter notebook to be precise. I linked the data sets. So when you go to the notebook, you can see the data sets, so you can always update it yourself. This is not integrated, so it's not updating itself, but that was also not the idea. So as I put in the notebook itself, the goal of the analysis was to work with Austria's open source data and see the ease of its use. Then I wanted to interactively plot the development of the deaths, because data itself is really worth so little as it is really prepared and cleaned. And this is also just a pre-step, because you need to do something with it. You need to analyze it. You need to visualize it, or anything else actually to make it understandable. And the last step that I did was I fit a polynomial regression, and I wanted to calculate the slopes at given points to see the change of the death rates. So that's what I want to talk about today. I want to just go through all of that, and also want to talk a little bit about technical solutions or choices that I made in order to get to this analysis. So I have multiple articles in this regard, so you can check it out as well. But I think the setup is very easy, and every programmer with even not a lot of knowledge can easily do something like that. And I would encourage you to do something like that, because nowadays media, doesn't matter which country you live in, they always sell themselves as being data driven or selling some data. The problem is that it is very intransparent on how they actually come to the interpretation or the visualization of data. And Austria is doing a great job in providing data sets for the public. And I think this is really the first step of becoming more transparent in decision making in politics. So I'm very, very happy that I had this opportunity here. And yeah, so when I started my analysis, and by the way, I recorded all of that. Took me around, let's say, around 20 hours, everything. I recorded all of that. I will also publish it as a time-lapse series. And yes, when I started, I was looking through the data sets, and sometimes the data is not so easy to use. So let's see, as an example, when I go through the death rates, so let's say Todesfälle, not 100% sure. So let's see, there is a monitoring, and I think they use, I think they created an own. Yeah, but I do not want to use that because I want to have another data set. What? Let's just get this one because I think that, what the fuck, that's bad. Let's have it like that. So when you look, so in generally speaking, when a company, public authority or someone is making data accessible to you or the public, they always need to do it in some format, right? And so when you look into the data here, it's already, so you have some naming that is not 100% clear. So you have calendar week, I guess. You have groups of ages and ans, meaning number, also indicating that the type is numeric. So I can already not really see what the data is trying to tell me. So when we look into the description, there is some better description. So it says here it is the country, it is age group, it is the gender. So stuff like this is available, and that's great. However, of course, there needs to be some pre-processing along the way that needs to be done. So when we look at the notebook, and you can see that that first, of course, I need to load the data, and as always, you do some data cleaning. Data cleaning has so many implications, but in this context, or when I talk about this, it means that I prepare it for my next steps in my analysis. So it can be seen differently. Cleaning sometimes means performing removal of certain columns or rows, but in this scenario right now, it is about preparation for anything that will follow. So basically, if we go through the notebook altogether, I imported a couple of libraries, not so important. So maybe just quickly, so many people in the analysis field are familiar with those libraries. NumPy, Pandas, it's for data manipulation and calculations. Pandas profiling is for a quick exploratory data analysis. Then we have Plotly, which is used for data visualization. And then we have scikit-learn, which is for the calculation of regressions. So what else do we have here? First of all, I load the data. So it's two data sets. One is the people that died and the people that died because of COVID. And what is very important here to note is that, and I was curious about this as well, I did not elaborate on it in the notebook here because, this is just a side project that I did. It's not a study, it's not a publication or whatever. However, it is very interesting on how the countries relate to the deaths that are related to COVID. So in Austria, when you look at the official dashboard, There is an official dashboard in Austria, and you also have at some point Erläuterungen, where you have basically explanations. And here it says, because I was wondering how they come to those numbers, so they say verstorben, meaning dead, is someone that in between of the state of being sick and being dead, there was no recovered state. Meaning, and this is important to understand in terms of data quality, that of course just having COVID doesn't necessarily imply that the person died because of this. There have been studies, and I was also looking through that. You can see that in the time lapse. Of course, there is a correlation, and I think there was a study that was saying that around 80% of the people in a certain age group, meaning above 65 years, their death heavily correlates with the the COVID infection, because it makes basically everything worse. But anyways, as I said, I will not go into that because I merely focus on the raw numbers and the analysis thereof. So when we load the data now, we can load both data sets. And here we see the one that I showed you before. Obviously, you need to do some data preparation, because you cannot work with that. So you have strange formatting of the calendar weeks. You have the countries of Austria here, or the states that are encoded in an interesting way. Age groups, the gender, very interesting. So this is not, of course, this is not done in a very, with the idea of having many people using it, but it's workable, and that's already good enough for me and everyone else that wants to dig into that. The other data set is a little bit more prepared and already yes, a little bit clean. So you can see the date is already proper date format. You can see state ID, the names. So everything is very, very clear and nice. So not a lot of preparing to do with this one, and a lot of preparing to do with this one. So I think this is a nice example to show what is involved with analyzing data, open source data, or data in general. So maybe quick note here on this. What I did before, you can see it in the time lapse as well. I always do a quick exploratory data analysis, meaning that I create a profile report. You can have a look yourself for pandas profiling, and they basically give you very, I would say, simple descriptive statistics, and also some correlations. And I do this to check if the data set is workable, right? Because you need to, or I need to check if the data, seeing that there are 42,000 rows, and here 5,000 rows, that I cannot check everything. So I need to have some exploratory data analysis performed. The reason why I commented it out was because the report creates or uses a lot of memory space. So that's why I just commented out. But if someone wants to have a look at it, yeah, you can just out comment it again and then see the results. Let's go further. So basically, as I said, it was important to clear the or format the dates, or the first data set, but here more specifically dates. And dates are always annoying to deal with and handle because there are so many ways on how you can work with dates. And as a data scientist or data analyst, you will know that pain. And I actually spent a couple of I'm not sure, maybe even hours. And I don't think so, but at least a couple of minutes on this process here. And basically, what I did is transforming these calendar weeks into a proper date. You can just go check through the code yourself, nothing special, but as I said, it takes quite some time to get to the point where you actually want to have your date. Then I aggregated the dates because as this one was split into states, I would need, of course, to aggregate the the counts of the deaths, and then I could use it. So what else do we have? We have the second data set. That was a little bit easier because you already had a column with, or you already had basically a column that indicated the numbers for whole Austria, so that's easier. However, what I needed to do here was, because this was cumulative numbers and not per day, so I basically needed to find the change, so the infections or the deaths per day that came new to it, because of course if you just plot it, and I think I did, but it's not here anymore. Yes, you can clearly see it was cumulative, meaning that you just add up the new ones instead of showing only the people that died. So what I did here, I was again formatting the date a little bit to my wishes, and then I did the deaths per day, which is basically in the diff function here with pandas. And then if you plot it looks like something like this, which is interesting because you have quite a big jump here, and this was due to some correction of the numbers of the death rates. But yeah, you can clearly see, so there are certain periods where there are more people dying. I mean, you can also have this in a log scale to just avoid this one, or you can clean the outliers, but that is not the point now. I want to show something else. So the next step was to merge the data sets, to actually work with one data set. And here I was also removing the outliers, but I did that was very kind, because I just ditched the very most outside outliers with the quantile function here, looking afterwards something like this. So now you can clearly see, if we take that data, we can see the deaths, and then we can see, so first of all, we can see some cycle here, but then we can also see the corona deaths, and we only have it, or at least the data had it, starting from, I don't know, what was it, 2021 in April. You can already see that there is a big difference here. So this now I'm, or in general, you can see this is already using the what's it called now, the visualization tool, Plotly. And you can just go through that code on your own. What I wanted to do next is to build a regression with the ordinary least squares. You have this function here within Plotly, basically just drawing a red line and showing you the statistical information about the regression, which is nice, but of course not very precise. So that's why I first of all did an implementation in scikit-learn, and then switched to a polynomial regression to model the changes a little bit better. And as a next step, and this got actually really complicated, and I was spending a lot of time in this. I was also publishing Stack Overflow answer to this because there was nothing available for Plotly, which is basically when you want to show the slope on a specific point for a regression, you need to actually, of course, calculate it, because it's not the coefficient, it's not the slope that the function, the default function of any library might give you. So you would need, or at least to this day of recording and the day of, or the time of implementation, it was not available. So that's why I created a solution for that, which involved some calculations with NumPy library. I do not want to get into this now. You can have a look at this your own and try to understand it. Created an own function now for that, and what we can see in the result is that what I actually wanted to do, and what was the idea of the whole analysis in the first part, or in first glance, was actually to calculate the slopes of the polynomial regression. Because I want to see, so the idea or the thought was, I want to see if the change of the slope, meaning the rate that the death rates increases, is actually so much higher because of the COVID pandemic. And it might also be just the case that it's just the rise or the increase of population and just more people die in general. I've never seen any analysis of that. It always just meant, yes, we have corona, the people are dying because of COVID. But there was no real proper explanation given, at least not in the media I consumed. And yeah, it was always just giving some graphs with no proper explanation. So that's why I wanted to have a look at this my own. So I calculated slopes at certain times. So you can see this is 0.63, and if we go back here, so it's 2.19, so clearly much higher, indicating that at least in this time range there has been some event that definitely increased death rates in at least 2020. So this when 2019 when it started. So there's a clear indication here, or at least clear room for interpretations and further analysis. So now I in this section of the notebook, I only did this with corona deaths, COVID deaths. Again, the same play again, the same game again. And interesting enough to see that also for the corona cases, there have been some increase. Of course, this is now due to seasonal changes, meaning, of course, that in winter it's always getting worse. But I wanted to see that as well, because if you can see cyclic changes, seasonal changes in the death rates, in the total death rate, but also within the specific death rate that should cause the change as well, I want to compare those slopes and those changes as well. And that's what I did. And in the final product, or the final chart here, this was again quite an effort. And I think, at least to my knowledge, there hasn't been any visualization in this regard before. That's why I wanted to create it, also with Plotly, also making it available in Streamlit. And if you now have a look into this, so a lot of code, you can have a look for yourself, or if you have any question, just feel free to shoot me a message, then I can elaborate on this part more. So basically what happens here? So I plot the corona deaths again, COVID deaths, and now I have certain visualization and also some interaction where I can see how everything behaves over the time. So if I click this now, it just runs the slopes, the tangent line around the polynomial regression, and that's exactly what I wanted to see. And that was basically the side result of my small analysis here. And yes, so basically you can just drag it around here as well. Yes, also small conclusion. So you can clearly see that there was an increase of the death rates, most certainly correlated to COVID pandemic. However, it was a really nice exercise for me to actually validate some information that I received from official public media, but also nice exercise to explore some open source data sets. Yeah, there's plenty of room for further analysis. I'm still not very happy that you simply take all people that are infected with COVID and just label them as died because of COVID. But even if you, and I did this just as an example, even if you take certain ranges, intervals for people that would not die because of COVID, you still have an increase. So I think that's enough for me, at least for me, to conclude my analysis or finish my analysis. And yeah, it's a nice way to check some work on your own. And as you have seen, you can do it quite easily with a couple of libraries in a Jupyter notebook. So maybe if I'm getting more into a little bit more into the technical details here. So if you go into the GitHub, the open source repository, which is MIT license, you will, for one, first see that I published it on GitHub Pages, meaning that you can see the notebook here is in an own link, which is great. And the other thing is I put some information here again, and you can see, you can just install everything, run your Jupyter notebook, run it on your own. And I also created a Streamlit web server, so you can start that, and then it would look something like this, where you can just add the data and interact with it a little bit differently, but that's about it. So if you can see, the main function here for Streamlit is I think almost all is just copied, apart from, of course, the Streamlit code that is shown here. So very easy to transform your interaction or visualization into a Streamlit app, which is probably something I will explore in the next in my next project as well. Apart from this, that was it about this analysis, and I think I will submit this to the data, the open data website of Austria as well. If you have any questions, just feel free to reach out to me, and all the best to you.